Periodic table is a powerful tool in chemistry. If you are good in periodic table, you can predict the chemical properties of an element based on its location in the table. This table is full of elements named in different letters in the alphabet. Apart from just two letters, you won't find letter J and letter Q in this periodic table. Hi, my name is Rajesh and welcome back to Science Online. Today is about atomic structure and periodic table. This is for GCSE Chemistry students, and this foundation topic is very important to start your journey in chemistry. So let's start with atomic structure. Atoms made up of subatomic particles called protons, neutrons and electrons. The protons and neutrons are in the middle of the atom, the area called nucleus. Because these two are in the nucleus, these two together we call them nucleons of an atom. The electrons moves around the nucleus in energy levels. So the energy levels are the area where these electrons occupy. We have different energy levels. The energy levels closer to the nucleus called low energy level. The energy level further away from the nucleus is called high energy level. The electrons in different energy levels have different amount of energy. Let's look at a couple of terminologies: atomic number and mass number. The atomic number is the number of proton an atom has. So this is a unique number for an atom. So the number of the protons for an atom cannot change. If the proton number changes, the atom changes. The second one is the mass number. The mass number is the total number of protons and the neutron of an atom. Say for example, as you can see on the screen, when we write the symbol format, sodium has the mass number 23. We write it on the top of the sodium. And the atomic number of the sodium is 11. We write it at the bottom of the sodium. So this is how we display the mass number and the atomic number of an element. Periodic table is a powerful tool in chemistry. If you learn the periodic table very well, you can predict so many different things about an element based on its location in the periodic table. You can predict its chemical behavior and its pattern, ionization, formula, bonding, etc. etc. The periodic table you see on the screen is the modern periodic table which we use these days. It's a full-scale periodic table. For GCSE level, we may not need to use the whole table. We mainly use the first 20 element, the simplified periodic table. That's the one you start with. Like any other table, periodic table also arranged in rows and columns. The columns of the periodic tables are called groups. We have group 1 to group 8. Sometimes the group 8 is also called as group 0. The rows of the columns are called periods. In periodic table, elements are arranged in the order of atomic number. So the first element has the atomic number 1. The 15th element has atomic number 15. We already defined what is an atomic number is. It's a number of proton of an element. And in any atom, number of protons are equal to number of electrons. Now, in this periodic table, for example, if we take 15th element, its atomic number is 15. And therefore it has 15 protons. Since protons are equal to electrons, it also has 15 electrons. The electronic configuration is the format shows how the electrons are arranged around the nucleus of an atom on different energy levels. The first energy level holds maximum of 2 electrons and the rest of them holds 8 electrons. If you are going to do chemistry for A levels, you will learn a lot more detail about these energy levels. Now, let's look at an example. Let's take a sodium from our table. It's the 11th element on this periodic table and therefore it has 11 proton numbers. Since its atomic number is 11, it's 11 proton number and 11 electrons. If we write the electronic configuration for sodium, it goes as 2, 8, 1. So the first shell has 2 electrons, second shell 8 electron, third shell 1 electron. And if you notice, it has 3 energy levels. And if you go back to periodic table, sodium is in third period. So the energy levels tells you which period it is. And also if you look at the electrons in the last shell, sodium has 1 electron in the last shell, or the energy level. It's in group 1. So the number of electrons in the last shell tells you the group it belongs to. Let's look at another example, oxygen. Its atomic number is 8. So therefore 8 protons, 8 electrons. The electronic configuration for oxygen is 2, 6. See, it has 6 electrons in its outer shell. It's in group 6. It has 2 energy levels, and therefore it belongs to period 2. The third example, calcium, is the 20th element of the periodic table. Proton number 20, electron number 20. Electronic configuration goes as 2, 8, 8, 2. The last shell holds 2 electrons. It's in group 2. It has 4 shells or 4 energy levels. It's in period 4. So if you know the location of an element in the periodic table, you can predict its electronic configuration. You can say how many electrons on its outer shell. Remember, the number of electrons in the outer shell of an element decides its chemical property, i.e. how it's going to react. If you know the chemical property of an element, you can predict so many different things about that element, how it's going to react in a different environment, how many electrons it's going to lose or gain. See, we have already started to predict things based on this simple idea. This is the beauty of periodic table. My advice to Year 8 and Year 9 students, when you start to learn some serious chemistry, please learn the periodicity and periodic table thoroughly. It will open up lots of different doors in chemistry. You will find the chemistry much more easier and interesting. Hope you find this video useful. Until I see you in another video, bye everyone.